All right, so welcome back. We're going to continue with Java today. Probably conclude with Java, but then transition, segue right into Java or object-oriented programming in Java. We left off last time with file output. And like I said last time, the easiest way to do this is with what's called a print writer. There are a couple dozen ways of doing file output, but again, this is the easiest, most straightforward way, because once you've got a print writer, you can use all of the output functions that you're familiar with. So let me go ahead and import that. Now we do have a compiler error here, and that gets us into our next topic. Let me go ahead and increase the size here. Just for now, I'm just going to surround this with a try catch, okay? Don't worry about that just yet. That's what we're going to cover next. So print writer, once I've got a print writer, I can do whatever I want with it. I can go just like system.out.println. I can go pw.println. Hello, this is on one line, right? And it'll print the end line character for me. Or I can go pw.print. This is not on, or no end line character, excuse me. I need to shut off Siri. There we go. This is not, or there is no end line, right? And then, of course, you can also use printf, right? If you want to format a string, if you want to format a number, an integer, if you want to format a floating point number. And then, of course, you would have to add in the end line character yourself there. I'll go ahead and give it a string, hello, a number, 42, and then 3.15, or 4. There we go. There. Now, once you open up a file, you write to it. What do you need to do in the end? You need to close it, right? So pw.close. Failure to do it will usually, 9 times out of 10, Java will close it for you and it'll be fine. It's that 1 time out of 10 that, or 1 time out of 100, whatever it might be, that everything gets screwed up. So make sure that you are closing that file. So let me go ahead and run this now. Right. Nothing happened. Why? Well, because it wrote to a file. Remember that file was in the data folder, and that file was called output.txt. So let me expand the data folder over here, and we see a new output.txt with the contents that I had there before. Sometimes it doesn't appear right away. So for example, let me go ahead and output the exact same thing to a file called output2.txt. Hey, where is it? Right? Well, your IDE is basically a thin wrapper around your file system. Sometimes it picks up on changes in your file system. New files, files get deleted, et cetera, et cetera. In this case, though, it didn't pick up on that change. Don't worry, don't panic. All you need to do is right-click your project, go down to refresh, or just hit F5, and it'll automatically flush with the file system and see, oh, there's that output2.txt file now, okay? All right, remember we do have a question and answer up on Piazza if you've got questions. Otherwise, I'll go ahead and put this in the notes so that you have access to it. And note that I was just writing a bunch of fixed values. Of course, you could put in variables here instead of 42. You could store that off into an integer variable and print that with the value stored in that variable. Okay? So, what happened here? Why were we forced to surround this with a try-catch block? Try-catch is Java's way, and in fact, most modern programming languages do it this way, of doing error handling. Errors are things that are maybe anticipated, or in this case, they're called exceptions, right? This is called a file not found exception. Exceptions are interruptions to the normal control flow of a program. You're going along, right? You set up your output file. You open up your print writer by saying, I want to open this file. Any number of things could go wrong, right? File not found exception, well, I wanted you to create it, right? Well, maybe it failed in its creation because you didn't have permissions to write to that directory. Or if you're reading from a file, certainly if it's like a password file, you wouldn't want to just anybody to have access to that file. So file not found exception, that's kind of a catch-all, right? That's a catch-all for anything that can go wrong. There are lots of other types of exceptions. For example, more generally, there's an I/O exception. you can catch different types of exceptions. IO exception, and I think I can name it the same thing. And then I can do print its stack trait. Oh, I have to spell it correctly. There we go. And I also have to import it, right? So if an IO exception happens, a different type of exception, then this could happen. The approach to error handling in Java is one that's completely different if you're coming from a background with C. C, you do defensive programming. You look before you leap. You look and say, am I about to do something illegal like division by 0, right? And if you're about to do that, you don't do that, right? Instead, if you're in a function, you return an error code, or you just don't do anything, or you raise a system error or something like that. With Java, it's different, right? Instead of looking before you leap, they say, go ahead and leap, right? And if you're falling off the edge of a cliff, don't worry, we'll catch you, thus the keyword catch here. Go ahead and try this dangerous thing. And if something goes wrong, we'll catch you if you fall, and then put you back up, and then you can decide what to do with that error, right? So it's not defensive programming. It's go ahead and do whatever you want. And if you don't have this catch block here, then that's fatal to the program, right? So that's the idea. That's the basic idea. Again, Java supports exceptions for error handling. Let me go ahead and put this in the notes here. An exception, as I said before, is an interruption of the normal flow of control in a program. Potentially dangerous code can be surrounded by a try-catch block. Right? If an exception is thrown, right, and we use the keyword throw if we ever want to manually throw an exception, then the catch block will catch it, just like it says on the tin, and you can handle it in that block, right? For example, now, unfortunately, I'm going to tell you that it's normal practice, maybe even best practice in a lot of people's opinions, to let all exceptions be fatal, right? How can you recover from a file not found exception? Well, if you're reading from a file, maybe, okay, well, there's no file, so I'll go ahead and create a default file with no data in it that's properly formatted. That's a reasonable assumption. But if you don't have permission to write or to read from that file, the file exists, but you don't have permission to it, or you're trying to write a file and you don't have permission to write to that directory, how can you reasonably recover from that? In fact, this is a flaw in the design of these things, and it was kind of quickly realized that it was a flaw, and nobody has ever really adopted this idea since. In Java, you can have actually two types of exceptions. Java has two types of exceptions. One, a checked exception, which requires you to surround the operation with a try-catch block, and an unchecked exception, right? So this is why I had to resolve that compilation issue, right? I had to surround this with a try-catch. If I didn't surround this with a try-catch, let me just go ahead and show you again what it's going to complain about here. I'm going to go ahead and get rid of that try-catch. It starts giving me this compiler error. Unhandled exception type, file not found exception. So way back in the beginning when Java introduced checked exceptions, it was the first, I believe it was the first language to do so, they thought in their design that, look, if you can reasonably recover from this exception, then we're going to force you to have a try-catch, and we're going to force you to recover from it somehow, right? And that's where the idea of checked exceptions comes in. And to this day, 25 years later, you still have to deal with these exceptions. Since this idea, no other language has introduced checked exceptions. Many languages have exceptions. Only C++, to my knowledge, has the option for checked exceptions. And note that it's an option. It's never, and it's not something that I've ever seen really people like be very, very enthusiastic about. Why? Because why are you forcing me to do error handling in some particular way, right? I don't care about a file if not found exception. If the file is not found, then my program should die, right? I want this to be a fatal exception. So how do we deal with checked exceptions when it should be fatal, right? In general, you should go ahead and try it. You have to try and catch it. So for most checked exceptions, go ahead and try catch them. But then, so any anglers, fishermen? All right. So do you keep the fish that you catch and eat them? If it's big enough. If it's not big enough, what do you do? And that's called catch and release, right? But then release it, right? By throwing it as a new runtime exception, right? So we got this, we tried this dangerous operation, it failed, we caught it, but I can't handle it because I can't magically create a file that should be there. Or I can't, if you're connecting to a database, a lot of stuff can go wrong. You can maybe have no network connection. Maybe the password that was provided was wrong. Maybe your SQL code that you are connecting to the database with is malformed, right? You misspelled a word or something. Millions of things, no, not millions, but many things could go wrong that you cannot, like the server is down. You can't magically reach across time and space and plug it back in, right? You can't reasonably recover from these exceptions. So what we're going to do is we're going to catch it and release it. And what I mean by that is simply, let's go ahead and restore this. I don't know how to handle a file not found exception. So instead of printing out a stack trace and going, I don't know, right? What I'm going to do is I'm going to rethrow it. Throw a new runtime exception. Runtime exceptions are unchecked, right? This is the most generic form of a non-checked exception, an unchecked exception that you can do. And what I'm going to do is I'm going to take this exception that I was caught, this file not found exception that I'm calling E, and I'm simply going to rethrow it as a runtime exception, okay? And when I do that, then that's how you handle it. And you can have multiple catch blocks if you really want to. Just like a else if condition, the first one that gets matched is the one that occurs. So you can have the most specific types of exceptions up here, then less specific, then more general, until you get down to the end, and the most general type of exception that you can ever hope to deal with is an exception, right? And there, well, I believe that this is an unchecked exception, so it doesn't matter if you catch it and rethrow it or not. You can just let it be fatal, okay? Here's the idea with a little bit more substantial example. Let's see. Let's do something that could result in multiple errors. So let me go ahead and create int n is equal to -10, right? Well, let's go ahead and open up this file. What's my input file again? Oh, it's computer. Okay, that's good enough. Let's go ahead and open up that file, but we'll make the assumption that there should be an integer in there that we should read. Obviously, there is no integer in there, right? It's just the word computer. So what I'm going to do is I'm going to try to open up that file. I'm going to try to convert computer into an integer, and many different things could go wrong. Actually, let me go ahead and make this into 0 here, right? And what I'm going to do is I'm going to try to open up that file. File f is equal to new file, and it's in the data directory input 001.txt, right? And I'm going to use a scanner to scan the first line of that file. Right? And I'm just going to get, I don't care about going to the end of the file, I'm just concerned about the first line. So .s.get, or next line, sorry. There we go. Nope, I want next line. There we go. And I'm going to store that into a string, str, since I've already used s here. And then I'm going to try to convert that over to an integer. Int x is equal to integer.parse int of str. There we go. So first of all, let's complain. Lots of things could go wrong here, right? This parsing is definitely going to fail because you can't convert computer into an integer because it's not an integer. And certainly you wouldn't be able to do this. Int y, or double y, is equal to x divided by, or not 0, but n. Let's do that. Right? So lots of things could go wrong here. There is no file. The file is malformed because we expect an integer, but we get computer instead. We divide by 0. Lots of different things could go wrong here. So let's go ahead and start dealing with them in some manner here. So first of all, I'm going to have to surround this with a try-catch. And by the way, the more modern way of doing this in Java is to use a try with resources. Let me go ahead and show you what that means. Scanner s is equal to new scanner on f. Right? I'm instantiating it in the try block here. That way I don't have to create it over here. That way I don't have to do anything with it inside. And not only that, and let me go ahead and bring all of this up here. Not only that, but that close, s.close, that's done automatically for me by using this syntax. You're going to try to use this scanner in this block, and that syntax will automatically close that resource for me. This is a superfluous line. You don't need this anymore. Right? It'll close it automatically for you if you use this syntax right here. Right? But otherwise, the scanner could fail because there's not a file not found exception. Let's go ahead and catch and release. Throw a new runtime exception. E. And note here, I'm just taking E, I'm wrapping it up into a new box, and I'm throwing that box. Right? Let's go ahead and run this. Of course, it's not going to, that file is there, right? So we're not going to get this file not found exception unless we misspelled it, right? Input 0, 0, right? There's no file like that. So we're going to end up with a runtime exception, which is a rethrown file not found exception, data input 00.txt, no such file. Right? That makes sense because we misspelled it. Right? Let's go ahead and spell it correctly and run this. What's the next possible thing that could go wrong? This parsing right here. And what type of exception is that? A number format exception. Right? So let's catch a number format exception. And note here that the compiler didn't force me to do this, did it? Why? Because it's an unchecked exception. If we don't do this, you can see what happens here. All it does is say, oh, I can't do anything with this. This all started at line 19 when we tried to parse it. The parse int called another parse int called another function, etc. This is the full stack trace right here. You could go to the line by clicking this blue thing, but I don't think I have got the. Oh, I do have the Java source, right? You can rip open the integer class up here and start looking at the internals of the built-in classes in Java, right? You can also look. But generally, you want to limit your scope of attention to your own code. So, like line 19 right here, right? By clicking that, it takes me right to the line number through that. And what's the problem? Well, computer is not an input, is not a number, so number format exception was thrown. Let me go ahead and restore what I was about to do. Let's go ahead and catch the number format exception and say to do use a sensible default value. Right? And I'll just put a to do in there. I don't have any code in this catch, right? And that's perfectly valid too, right? Although if you don't have any code in this, why did you catch it, right? For a checked exception, it makes sense to catch it and then do nothing if you really want to. That's not a fatal exception. I'll just go on with the rest of my program. But if it's a fatal exception because you need to open this file and you need to process this file, but no such file exists, go ahead and throw it and kill the program. Right? If somewhere up in the stack, function calls function calls function. If somewhere down in the stack, I should say, some other function chooses to catch that exception and deal with it, that's perfectly valid too. All right, so number format exception, I'll just put in a to-do, use a sensible default, system.out.println, computing with default values, ... whatever we're trying to do. Of course, this is just a made-up example. All we're trying to do is read a number and then divide by 0. Right? So computing with default values. Let me go and get rid of this error. Let's say 42. Right? Now, this number format exception should not be thrown on line 19 because it'll read 42 and convert it to 42. But then we immediately divide by 0. So let's see what kind of exception occurs there. What kind of exception? An arithmetic exception. Okay, well, I can choose to catch that too. Catch arithmetic exception E, and to do deal with this somehow, right? And like I said, it's an if-else-if condition, so you have the most specific going to the most general. Now, I don't know that these are more, one of these is one type of another, but if you want to catch any other type of exception, all exceptions are exceptions. So to do deal with this exception somehow, right? Deal with not this, but a generic exception somehow, right? That's just like your else statement in if, else, right? This is the last possible thing that could possibly happen, and you deal with it somehow. Again, usually you catch and release. You throw a new runtime exception E. Whatever could happen. As it is right now, it won't say anything. Why? Because an arithmetic exception occurs on line 20. We catch that, but we choose not to do anything. And then normal control flow continues afterwards. System.out.println end of program. And you'll see the end of program actually gets printed. Why? We chose not to do anything about that arithmetic exception. So normal flow of control returns to line 32. We print this out, and that's where the program ends. Okay? Those are exceptions. And of course, you can make your own type of exception if you really want to. But otherwise, you know, you can use a runtime exception as a generic exception, and just provide a message, right? So what I mean by that is you can go with the defensive way of doing this. If n is 0, then we're about to divide by 0, right? I'll put this in the else block. Right. And what I can do is I can throw my own type of exception. I will throw a new runtime exception with a custom message. You cannot divide by 0. And there we go. There's my message. Right? And now when I try to do this, right, I will end up throwing it, and there's my message. You cannot divide by 0, man. Right? Otherwise, you can go ahead and do your dangerous stuff down here. Right? I'll go ahead and put that in the notes too. Also, you can throw your own exceptions. There. No questions online? Any questions here yet? No? All right. That's basic error handling. Most of the time, you won't need to do defensive stuff like this. If you have an exception, that should be fatal. It should just kill the program, right? If you cannot reasonably recover from malformed data, 99% of the time in my book, at least. Okay? Okay, so our last item for Java, is going to be searching and sorting. And that basically takes us all the way up to the last topic of a Computer Science 1 course, where how do you use the build? Usually the way that I present it is, here are a couple of sorting algorithms, here's binary search, here's linear search. Now don't roll your own. Don't write your own don't write your own functions to do this. Instead, use what's built into the language. And that's what I'm going to do here. So suppose that I have an array of numbers, and I want to sort it. I'm going to go ahead and get rid of all this. There we go. Don't worry about this. This is just a quick and easy, dirty way of creating a list. You can also sort arrays, but again, like I said, arrays suck. Let's not use them. Let's use lists, sets, maps, right? These dynamic data structures that will automatically grow and shrink, and we don't have to worry about the low-level details. If I want to take something out, there's a method to do that. If I want to clear it out and remove everything, there's a method to do that. But this one, I've got a list of numbers. Negative 42, 4, 7, 3, 8, 2, 1, etc. And let's go ahead and print it out. System.out.println A. And when I print this out, it's going to look like this, right? Exactly as the input here. So how do I go ahead and sort this? There is a nice function called collections.sort. Nope, undo that. There we go. A. And after I've sorted it, I need to bring this in. It's in the java.utils library, just like where Java utils, arrays, collections, hash map, list, map, all the scanner set. Most everything that we've used up to this point is going to be in that utils package, or util package. What is util short for? Utilities. So Java utilities, okay? When I print this out, then it's going to be, oops, there's a compiler error. There, okay, I just didn't save it. There we go. All right, excellent. It's sorted, but in what order? What order is that? Ascending order, right? What if I wanted to reverse that order? I wanted descending order, right? Or what if I wanted to sort strings? Let's sort strings first. List of strings. By the way, can you sort a set of strings? Good question. What's the difference between a list and a set again? A set is unordered. Can you sort something that's unordered? No, right? So you can only sort lists. You can't sort sets. You can sort maps, special kinds of maps. There it gets tricky, though. So, I mean, generally, if you want a map sorted by values, you dump the values to a list and then sort that list. You don't generally sort the map because a map is also unordered inherently. Okay. So let's go ahead and go with a list of strings here, and I'll call it B. Arrays.asList. Apple, banana, orange, and zebra. I'm going to put zebra over here. There we go. And let me go ahead and print these out. Before I do, though, tell me which one of those strings comes first. If I were to sort it, which one would come first? One of these apples, right? Okay. Which one would come first, though? Capital A apple. Why? It's going by ASCII values. Lexicographic order, not dictionary order, lexicographic order. So as a consequence, uppercase A apple, what's next? What's the second value here? Uppercase B banana, right? Then apple, then orange, then zebra. Uppercase A apple, uppercase B banana, apple, orange, zebra. Why? Again, it is lexicographic order. That's the default sorting order. What if I didn't want the default sorting order? I wanted to sort things in descending order if they're integers. I want to go ahead and sort this array of strings in dictionary order. In other words, I want to ignore the cases. I want to ignore the uppercase, lowercase, case-insensitive sorting, basically. Okay? What you need for that is another component. This sorting algorithm right here, this sort, it knows how to sort. Given these two things, oh, they're out of order. I need to swap them. Or selection sort, you need to go find the minimum. Oh, here's the minimum. I put it at the front. I swap it with whatever is at the front, right? It needs to know, given these two things, does it go like this? Or are they out of order, and so they need to be swapped? Or they're equal, right? In C, what did we call that thing? That other component that we plugged into QSort. QSort knows how to order. Sort knows how to sort, but it doesn't know how to order, right? A and B. Does A come before B, or does B come before A, or are they equal? That thing is called a comparator function in C. In Java, what do you think it's called? A comparator, right? Now, just like the list, where it's parameterized for this integer, this comparator is parameterized for an integer. In other words, it compares integers. If you try to give it a string, this comparator is going to fail and say, I don't know what the hell you're talking about, because I'm a comparator for integers. It'll call this CMP int by ascending, or right, because it's the default order is ascending, and so this will be for descending. Right? Now in C, this would be a function, right? It would be a function, and then you would pass it to another function as a function pointer. Here in Java, it is a full class. In fact, this is technically an interface. We won't get into that just yet. All I'm going to do is show you how to create one. I want a new comparator, again for integers, and right here I'm going to define what it does. First of all, let me bring in this interface. It's in Java util as well, and it's going to complain about this because given A and B, it doesn't. You need to define how to sort them, right? So let me go ahead and add unimplemented methods. That's where we get this compare method, right? Just like a string.compareTo or a string in C, strcmp, it returns something negative, positive, or 0, depending on the relative ordering of elements. So I'll rename them over here, A and B. If A comes before B, we should return something negative. If we want to go in ascending order, 5, 10, right? We want to go in ascending order, so 5 comes before 10, and we return something negative. Or 10, 5, they're out of order, and we want to return something positive. If we want descending order, that's the default order, we need to specify that business logic, or that logic. If A is less than B, right, 5, 10, we want descending order, so they're out of order, so we should return return something positive, right? Else, if A is greater than B, well, they're in order, 10, 5, we want to go in descending order, so I'll return something negative, right? Now something, you might be able to encode, or you might want to design your comparator to encode some additional information in that. It doesn't matter. In general, though, this compare method just simply needs to return an integer that has that contract, something negative, positive, or 0, depending on the relative ordering of the elements. Else, what's the only other condition here? Return 0 because they're equal. You do not have to put if A equals B. In fact, in this case, they're big I integers. You can't do that. It would be comparing memory addresses, just like it does with strings. So I'm going to go ahead and put in else. Now that I've got my comparator, I can use that comparator in the sorting algorithm. Let me go ahead and cut and paste that. Let me give myself some more room here. And let's look at exactly what I did before we see that running. So comparator, and then I parameterize it. This is a comparator for integers, and that's where this integer and this integer came in. If I did string and string, obviously it's not going to compile anymore. Hey, you said that this is a comparator for integers, and your compare method here is taking 2 strings. Those have to match. Then I create a new comparator, just like we've done a new list, a new hash set, etc. Right? I use that empty diamond syntax, and then this is actually a constructor, something that we'll talk about later. I'm actually calling a method here. But then instead of immediately semicolon, I have an opening curly bracket, closing curly bracket, where I define exactly what this comparator is right here, right now, in this lines 30 through 42. Right? I could make this its own class if I really wanted to, but there's no point. The only purpose of this class is to hold this method. And once I've got that method, then I can give this comparator, I can give it to sort, I can give it to that sort if I wanted to reuse it or whatever. And so there's really no reason to create an entire other class for it. For that reason, this is called an anonymous class. It's not called my awesome comparator. It's not called my integer comparator for descending integers. Right? That's what the variable name is called, CMP int desc, right? It doesn't have any name, and so it's anonymous, right? If I were to create this into its own class, of course I would have to give it a name. I would have to create a new class, and I would have to give it my comparator for integers, that which goes in ascending order, right? Some complicated name or whatever. You don't have to do that. No name, anonymous. All I'm doing is defining it right here in line. It's called an anonymous class, okay? Now, how do I use it? Well, there's another sort function or method that takes a list or a sortable collection here and a comparator. Right? And when I run that, of course, it'll now be in descending order right here. What would it look like if I wanted to do the same thing, but for the strings? But instead of, I'll keep ascending order, so I want A's before B's, C's, D's, etc. But I don't care about the case, so I want those apples together. Right? Let me go ahead and cut and paste this, and let's modify it. So it's no longer, I shouldn't call it a comparator CMP int desc. I should call it compare strings case insensitive or ignore case or something like that. It's no longer a comparator for integers. It's now a comparator for strings. Right? And it's complaining about this because, of course, I've got syntax errors down here. Not syntax errors, but compilation errors. You said that this is a comparator for strings, so I need to take in 2 string values. Right? Now it's happy about it up here. We'll come back to this business logic right here in a second. Or not business logic, but the comparison logic. And I want to sort that collection with that comparator instead. It's complaining. Why? The method sort, the type collection, is not applicable to the arguments integers and strings. What was A again? A was a list of integers. You cannot sort a list of integers with a comparator for strings. Right? Those types are incompatible. The list of strings was called B. Right? So if you're mixing types in Java, it's not going to work. Okay. All right. Let's see. This won't run, of course, because we still haven't implemented our compare method up here. Okay. So how do I compare 2 strings? I've got A versus B. Could I do what I did before? Return something negative? No. Less than is for numbers. Right? Well, certainly if it's equal, I could return 0, right? Nope. Even in C, you couldn't do this. In C, what would this mean? Here's a string, a char star. Here's a string, char star. Equals equals tells you what about these char stars? That they're the same pointer, that they're pointing to the same memory location. And that's exactly what Java is doing here. This will not work. You're comparing memory locations. Okay? Question online, why is compare int A and B not compare int A and B? Good question. So the question online here, just to go back a little bit, instead of int, I could put int. Small I int does not match big I integer. And unfortunately in Java, you cannot parameterize based on primitive types. It has to be, that's why we have, one reason why we have these wrapper types. I cannot create a list of ints. I can't create a list of doubles. I can't create a list of chars. You have to use the wrapper types. Right? And consequently, they have to match over here. Yeah, go ahead.
So you said that it's comparing the memory addresses. Why is up on the integer one?
Okay.
So if A, isn't that the memory address of A less than the memory address of B?
Good question. They're called wrapper classes because they're inside. What do you wrap? You wrap up a box, right? What do you have inside your box? You do have a lowercase I integer, int in there. And so what's happening is Java is automatically, and this is what they call it, it's automatically unboxing it for you, right? These wrapper classes have wrapped this up into a box, and it says, oh, I know, well, okay, I know that you meant that you want to compare the value stored in A and the value stored in B, so I'll unwrap it for you. Basically, the compiler is going into your code before it actually compiles and replacing it with .intval, which returns a lowercase I int, and it will replace this with .intval. And you can see that it returns an int here, but it's really small, right? And the compiler is magically changing your code so that you don't have to, this is kind of messy, right?
So can we use the equals equals to go A equals equal B?
You can if you cross your fingers and hope. Sometimes it will interpret it correctly. 9 times out of 10, it will not. Right? That's, in fact, why I went with this pattern, so I didn't even have to, I avoided that problem entirely. And I didn't even have to use equals equals. By process of elimination, equals equal. They're equal, right? The other one is, do you need the override this is called an annotation. No, you do not need it, but we'll talk about it later. It was auto-generated by my IDE, by Eclipse here. Basically, this gets into object-oriented programming inheritance, that this is an inherited method from the interface, and so we're overriding that method. You can take it out if you want to, but just go ahead and leave it in. We'll talk about that later on. Basically, it's a nice annotation to get a habit of using, because if you try to override a method that doesn't exist, then this will be a compiler error. Right? But if you leave it off entirely, then you'll never know that you did something wrong. Right? All right, so back to the logic at hand here. Good questions online. How do I compare two strings? A dot compare to, right? Well, compare to is not the same thing as compare, but it has the same contract. If A comes before B, then it'll return something negative. If B comes, if you want to switch them, I need to compare it here. Oops. Here's another string. There. I'm going to compare it like this. Of course, you could go ahead and reverse that, right? Or you can multiply it by -1, because 0 multiplied by -1 is still 0. Anything positive times -1 is going to be split to negative, negatives flip to positives. Right? I'll go ahead and go straight forward here, though, because I do want in ascending order. A's, B's, C's, D's. If this returns something negative, then I'll return something negative. Right? Else if A dot compare to B returns something positive, then I'll return something positive. Otherwise, hello and hello might be the same thing, so we'll go ahead and return 0. Right? Did I really need all of those if statements? If compare to returns something negative, then I return something negative. If compare to returns something positive, then I return something positive. Otherwise, if compare to returns something 0, I return 0. How could I greatly simplify this? Just return whatever it tells you. Right? Now, this will be the exact same behavior as before, because that's the default behavior. Apple, banana, then apple again. What if I wanted case insensitive? A dot compare to, ignore case, B. Right? And when I do this, now both of my apples are at the front. Of course, the uppercase A apple, by virtue of it being first here, was placed first. But if you've got a tie and you want more complicated logic, or you've got a custom class, which is what we're going to get into next. If you've got a class of students, and you want to order them by last name, then first name, or you want to order them by NUID, or you want to order them in GPA, ascending, descending, or whatever complex logic you want, all you have to do is codify that logic here in a comparator in the compare method. All right? Questions so far? We'll get some more practice with this as we start getting into classes here in a second. Yeah, in fact. But before we do that, let me go ahead and make sure that this is in the notes for you. And there we go. It's in the notes. Let's go back to what we've been working on this entire time. First of all, let me go back and chart my project progress here. I got all of Lab 2's done, so I'm back up to 100% here. There's today, right, with the red, and this is my Gantt chart here. I'm severely behind. Or no, this is a good rough draft, right? In fact, I'm almost nearly there. I only have this one line now to complete this. So let's go ahead and finish this line, and then I'll mark my first draft as done. So how do I sort the collection? Suffixes. I need to sort that list of strings. Collections dot sort. And do I need to? Do I need to do anything special here? Well, maybe if I wanted to ignore case, I could go back to my notes and grab that comparator that I just made. But otherwise, the default values, the default sorting order is good enough, right? Computer, puter, R, TER, UTR. Does that match my expected output? That's not my output. Oh, you know what? I think I got rid of it. Yeah, I overwrote my test case. Did anybody notice that? Remember my output originally was basically this stuff right here, right? Well, that's cheating, right? Never take your output from a program as your expected output. That defeats the whole purpose of writing a test case. So let's go back to the handout here, because the handout actually has the expected output for science, right? Let's do that for science over here. Instead of the input, okay, I need to run this as a command line argument, and we'll go ahead and go with science instead. Apply that, run it, and let's see if we get that output. CE, science, E, ints, ints, and science. So at this point, I am 99% confident in, I haven't done lab 3 yet. For me, that means grading it all, but I've got my first draft done, right? Debug, refactor, clean up, right? I'll say that I'm about 50% done with that because I've only done one program, right? And I need to do the rest of it. And I'm giving myself at least 2 days to deal with any eventualities that come up. So I would say I'm confident that I'm kind of caught up right now. Right? And this program is ready to go, but I don't have it cleaned up. Let's go ahead and polish it off. Don't leave to-dos, right? Let's go ahead and I reformatted it already, but if I didn't have good formatting before, let's go ahead and reformat it. Let's make sure that, oh, okay, good, I've got documentation there. I've got author documentation up here. Probably want more than just that though. You know, Chris Burke, my email, CSCE 156, fall or spring 2021, right? Et cetera, et cetera. Whatever else you want to put in there. Whatever you might put at the top of an English paper for a header, you might want to put in here for at least for assignment 1. Okay. All right. Well, I've only done one program. Let's do another, right? Because I've covered everything that I've wanted to cover as far as the core of Java goes, except for classes. Right? So let's take a look at this program first of all. The rate of decay of radioactive isotope in given terms of its half-life h. In other words, if you've got a radioactive isotope, uranium or something like that, or plutonium or something like that, it's giving off radiation. It's giving off gamma radiation, beta radiation, maybe even neutron decay or something like that. But eventually, it's not going to stay radioactive forever. You know, after, for example, strontium-90 has a half-life of 28.9 years, meaning that if we started out with 10 kilograms of strontium-90 in January 2009, then by the end of October 28.9 years later, we would expect to have only 5 kilograms of strontium. Now that doesn't mean that it just evaporates and disappears. You have 5 kilograms of strontium-90 and 5 kilograms of yttrium. I don't know how to pronounce that. Anybody? Yttrium, okay, 90, and zirconium-90 isotopes, which strontium decays into. Eventually, radioactive isotopes do decay into stable elements. At which point they're no longer radioactive, and so that's what they're going to stay like for the rest of their life, unless you make them radioactive by nuclear reactions. Okay, so our program is going to take in the following input: the atomic number, the element name, the element symbol. In this case, strontium was SR. The half-life of the element, the initial mass in grams, and then we'll compute a decay table here. So if I started out with strontium-90, 10 kilograms, after 1 year, I would expect to have 9.76 grams. After 2 years, I would expect to have 9.3 grams, right? Until I get down to that 29th year, right? Because the half-life is 28.9 years. At that 29th year, that's when I've dipped down below half of the original, okay? I'm going to go ahead, the original assignment here called for all of these things to be taken in as command line arguments. Before I proceed here, I'm going to close everything first of all, because we're done with all that. Let's think, right? An isotope is multiple things. An isotope is all of these things, right? It's the atomic number, it's the element name, it's the symbol, it has a half-life, right? And maybe you have an initial mass. I've got at least 5 things here. Whenever you have more than one thing that, or more than one piece of data that constitutes, that's all grouped together, right? In C, what did we do? If you've got multiple pieces of data that are just one thing, or what did you do in, if you've already taken a look at Lab 3 this week, there's a baseball team, right? Baseball team is a team name, a city, a state, number of wins, number of losses, right? When you've got multiple pieces of data that you want to treat as one thing, right? What did you do in C? You create a structure, or a struct, right? In Java, we create a class. And that's what I'm going to do here. I'm going to go ahead and create a class. What does this class represent? It represents an isotope. So what should I call it? Isotope. Excellent name, right? Now, isotope with a capital I, again, in general, all of your class names should be upper camel cased. So if it was an isotope, a radioactive isotope, that's one word, right? Right, there we go. Radioactive isotope. It is one word, right? It's not 2 words. But in any case, I'll go ahead and go with just isotope here. Right? But if it were multiple words, you would use upper camel casing. Okay? Now this is my class that represents an isotope. First thing I should do is I should document that class. This class represents an isotope, a radioactive isotope. For more information, see the periodic table. And even that's not going to be enough because the periodic table only has the elements. It doesn't have all the isotopes, the hundreds of isotopes that you could possibly have. Or the theoretically infinite number of isotopes if you can have as many neutrons, extra neutrons as you want or whatever. But see the periodic table, I don't know, give me a periodic table link. All right. Here, pubchem. There we go. I'll just put this in as a link, right? See the periodic table. And when I hover over this and I get the documentation, I get this nice little link. If I don't know anything about the elements, read all about them, right? Nice. But that's good enough for now. That all classes need to be documented. All non-trivial methods need to be documented. Right? Even if it's something as simple as this class represents a radioactive isotope, and that's it. Right? Okay. Question online here. This isn't the actual assignment 1. No, I'm not doing your homework right now. We're just going to, not random examples, but examples from past years. Why am I in this class if I've never used C? Java isn't C, C isn't a necessary prerequisite, but a high-level programming language is. If you don't have any programming language background at all, then yeah, this is the wrong course. But you could take anything that I've been talking about and apply it to pretty much any language. If you're familiar with Python, right? Python has classes, and there you would. In fact, I think Python has structs as well. If you were in C++, that C++ has classes. If you have taken MATLAB has structs, right? Basically anything where you want to take multiple pieces of data, in this case 5 pieces of data, and you want to encapsulate it in one logical unit. That's called encapsulation. Now let's go ahead and define what an isotope is, at least as far as our data model goes. Our data model says that it's an atomic number, which is an integer. So let me go ahead and put that in here. Atomic number. Right. Now this is just the name of the variable. What's its type? It's an integer. Okay. This is going to look very similar to a struct that you might have seen before. It's not going to look very familiar with Python syntax. Python syntax would simply be something like this because it has no typing in Python. But here we do. We have int atomic number. Right? Element name. Well, what type is that going to be? Element name. A string, okay. What else was there? Element symbol. And generally, some symbols are only a single character, but a lot of them are, you'd run out of 26 characters pretty quick. Most of them are going to be two characters. I don't know that there are any 3, are there?
There are some that are unnamed, but I think it's been out
They're well, because they theoretically exist.
Yeah.
Of course, you can have an element, an atom with a billion neutrons in it, but of course that'd be huge, right? Well, it wouldn't be this huge, but it would be. Yeah, it would decay almost immediately. I'm sure. I don't know if there are stable elements with more than here. The actinides and the lanthanides, right? It goes up to 103, right? 103 elements, and then there are additional ones beyond that that are theoretical that have not been created yet in the lab. So string element symbol, right? For example, SR, right? What else was there? The half-life, right? So what's that going to be? 28.9 years, probably a double, right? Double. And I could call it H. Is that a good variable name though? Over here, we're in the world of physics and mathematics where they just love single character variable names, right? Is that too meaningful when you're writing code though? Unless there's a universally known like pi, but even pi is like pi, right? H here, you'd have to have a context to know what H means. Is that an uppercase version of Planck's constant or something? That's not even, Planck's constant is mu? I don't know, I don't remember. Anyway, H is probably not a very good variable name. Even if you're a physicist and you know that H is the universal letter for half-life in the context of my work, right? So let's go ahead and call it half-life. 1 or 2, is it 1 word or 2? I don't know, I'll keep it as 2 words right now, right? Correct me later, please, if it's, I think it's 1.
It's
Hyphenated, okay. Can we hyphenate something like that? No. So we don't hyphenate. Hyphens are generally replaced with underscores in a lot of programming languages. We're not going to do that though. Okay. So hyphenated, yes, go ahead and camel case that. And then the last one would be the initial mass, right? Double mass. I'll just call it mass. Right? Note here I did not call it lowercase m. Is that meters? Is that miles? Right? Call it mass. Well, whoa, wait. Is it pounds? Is it kilogram? No. Should it be pounds ever? Should you do any science in English systems? No. Okay, well, does that mean that it's grams? Or does it mean that it's kilograms? Right? We don't have, there are some languages that support typing systems where you can define that this is actually, this is not only a number, is it a double, but it represents kilograms. So that if you add, and then this one represents grams. So that if you add kilograms and grams, it will automatically do the shift for you. Those are called strong typing systems. We don't have that in Java. Their use cases, in my opinion at least, are extremely limited anyway. So how do we deal with this in Java? Documentation, right? The isotope also has a current mass measured in, and do we want to do, I think over here it says grams, so let's go ahead and go with grams, measured in grams. Right. I put that into the documentation so you don't have to go looking mass, is that mass in kilograms or mass in grams? You could, of course, encode it in the variable name itself, mass in grams, right? But not necessary, especially if you document it up here. Okay? Other questions so far? Oh, sorry. Do you submit assignments to the web grader as jar files? Not on the first assignment. No, you follow the instructions and you submit the source files. In assignment 2 and beyond, yes, there are instructions on how to submit those as jar files. But no, not on the first assignment. Okay? All right, so I've got this isotope here with these 1, 2, 3, 4, 5 representations. Okay? Now I'm going to go over to my demo class here. Once I've got a class defined, I can start building instances of that class. Over here, this class, this is just a blueprint. This is what an isotope is. Some isotopes have an atomic number of 5. Some isotopes have an atomic number of 3. Some isotopes have an atomic number of 7, right? If I want to create separate isotopes, I need to create instances of that class. Strontium or strontium? What was it? Strontium. There we go. And I'll put it here, 90, right? Is equal to a new isotope of, now, this is the syntax that we used for lists, for sets, for maps. I want a new isotope, and I've got this parentheses syntax right here. This is what's called. This is calling what's called a constructor, right? It's constructing. In other words, it's allocating memory, right, automatically for me to hold these 5 elements right here: this integer, this string, these 2 strings, and these 2 doubles. Okay. Well, let's print it out. Print ln strontium 90. There we go. Print it out. Ah, does that look like strontium 90 to you? Nope, it's isotope and then and then a bunch of garbage, or what seems like garbage. That's actually the Java virtual machine memory address. Right? I don't know how to print this, Java says, so I'm just going to print out, well, here's the class, and here is the memory location at which it's located. Not that useful. So let's go ahead and let's try to print out its atomic number. Right? Well, system.out.println atomic number is equal to, and then I'll concatenate strontium 90's atomic number. Now you remember how if you've got a structure or a class or whatever, and you want to access something in that class, what do? Dot, right? And again, this is in C, this is in Python. I think Python uses the dot operator, correct me if I'm wrong. I think pretty much every programming language uses the dot operator to do something. Strontium 90 dot atomic number. Right? Now that's the atomic number of this instance. If I had 2 isotopes, give me your other favorite isotope. Uranium 235. What's the atomic number of uranium? 92, right? Then that is a different element with a different atomic number. I've got 2 atomic numbers here, right? One for uranium, one for strontium. Now if I print this out, what do you think I'm going to get? 0, 0. Why? Did I ever say that one of them was 90 and one of them was 92? Or strontium 90 is not 92. What is it? 38 is its atomic number. Okay? I would expect, 38 and 92 here. But I never set them. Okay, let's set them. Strontium 90. I want its atomic number to be equal to, what was it, 38? I want strontium, or not strontium, but uranium 235, its atomic number to be 92. 92, right? Yeah. Right? And now when I print them out, of course they've been changed. 38 and 92. Right? The dot operator. You can access variables and set them, like I've done here, or you can access them and print them out or change them. Later on, if I really wanted to, I could change its atomic number to 42. Is that valid? No. You can't go changing an atomic number. You can change the atomic weight. That's where we get isotopes. You can add a bunch of neutrons and make it heavier element, but then it's going to be radioactive. Right? Okay, well, what else is there? Strontium. In fact, I'm just going to paste this. strontium 90 dot atomic, not atomic number, but element name is equal to strontium. There we go. Its element symbol was SR, capital SR. What else is there? Dot Halflife equals 28.9 years. So maybe we need to put that into documentation there. Isotope also has a current, an isotopes half-life is measured in years, right? In solar years, if you want to get technical, solar years, right? But years, and the isotope also has a mass measured in grams, right? I've documented that now, okay? So it's 28.9. What else? Strontium 90 dot mass. We'll initialize that to, remember, 10 grams, right? Lots of typing, lots of typing. Let's do the same thing with uranium-235. Element name, element symbol, half-life, and mass. We'll go ahead and start out with only, I don't know, 1 whole kilogram of weapons-grade uranium, right? Of 1,000 grams, that's 1,000 that's 1 kilogram. But these are not the same, right? Element name is going to be uranium, and I already told you that it was 92. The element symbol is U, and the half-life of 235 is what? I think 235 should be like 4.19 billion. 1, 2, 3, 1, 2, 3. There we go. 4.19 billion years, I think. Well, what's wrong? Remember we said that this was a double, right? Or what did we set this as? It is a double. Really? You can't represent that much? What's wrong? Okay, there we go. What was happening before? 419,000,000. What is that without the 0.0? An integer. What's the maximum value that you can represent with a 32-bit signed 2's complement integer? 2.147 billion or something like that. This goes beyond the range. That's all right. Make it into a double, and now you've got 16 digits of precision. That's more than representable by a double. But the 0.0 is important. What was it? 703.8 million? 1, 2, 3. Really? That small? Okay. So be it. This should be 703 million. I got it right? Yeah, this is good. All right. All right, well, I want to go and do more. I want what's your plutonium 90 or something like that. Or what were the other two? What about iridium or yttrium or whatever however you pronounced it? Zirconium, right? Or the several hundreds of different isotopes. Does this seem like a good pattern to go by? Every time I wanted to create an isotope, I create a new isotope and then I set all of its values over and over and over again. Nope. So what should I do instead? I should put this into a method. Those methods have a very special name in Java, in object-oriented programming. They're called constructors. First, let's take some questions online here. I guess there's only one left. Are there arrow operators in Java? There aren't arrow operators as far as this is concerned. This is not valid syntax here. There are arrow operators as lambdas, but the arrows there are the double arrows, I believe. No, they're single arrows. You can have arrows in Java, but they're used in a completely different context. In fact, if you check out my CS1 book on sorting, I show you how to, instead of using comparators, you can use lambda expressions instead. Lambda expressions are just anonymous functions, but go ahead and check it out. All right. So what I want to do is I want to create a constructor to do this for me. Constructors are very special types of functions, of methods. They have no return type. Normally you would have public, static, void, blah, right? Something like this. We don't make it static because we do want to make it part of the class, meaning that it now belongs to the isotope class. We don't have a dot, math dot square root, math dot sign kind of syntax anymore. Instead, blah is now part of the class, right? Or it belongs to instances of the class is what I should say. A constructor also does not have a return type. You want to construct an isotope, you know what that is. It's an isotope, right? So we're not going to return an integer. We're not going to return nothing. We're not going to even return an isotope. You can have functions that return isotopes and any arbitrary value that you want, but with constructors, you don't have a return type. The other part of constructors that are unique is that they have to have the same name as the class. No return type. I'm generally making it public right now. We'll talk about that later on when we talk about encapsulation at a deeper level. But right now, I'm just going to make it public. This is a constructor. Right? This constructor creates a new isotope with the given values. Right? Constructors don't generally need documentation in my book, at least for your assignments. If you've got a constructor, you don't need documentation, unless there's something special going on with it, okay? Now, this is called the default constructor because it takes no arguments. Let's start giving it arguments. Let's say that I want to take an atomic number. I want to take its element name. I want to take its element symbol. I want to take, what else was there? Halflife. And mass. There we go. And now what I can do is I can set each one of those. I want this instance's atomic number to be equal to atomic number. I want its element name to be equal to that element name. And I want its element symbol to be equal to that. And I want its half-life to be equal to the half-life given. And mass is equal to mass. A whole bunch of warnings here, and we'll understand that in a moment. But first of all, let's go back here and actually use this thing now. Instead of creating an empty isotope with default values, now I want to create an isotope with element number 38, strontium, SR, and 28.9, and no, that should be a 28.9, and 10 grams initially, okay? Now I don't need any of this stuff at all, right? All of those values are now set. Likewise, 92, uranium, U, this number, and then 1,000 grams. 235 is, that's not weapons grade, 238 is weapons grade. Okay, I don't remember. 235 is a precursor to 238. You have to irradiate it, and then you get weapons grade plutonium, uranium. But then you want, you want you want plutonium actually, right? All right. So there's strontium and uranium, but the atomic numbers are now back to 0. Something went wrong that is related to these warnings right here. Let me just hover over here and ask what this warning says. The assignment to a variable atomic number has no effect. I'll motivate this for next time because this is where we'll end it. Int x is equal to 42. X is equal to x. What does line 29 do? Nothing. It sets x equal to itself. In other words, it takes the value in x and then it puts it back into x. That's why I'm getting this warning right here. The assignment to variable x has no effect. Exact same warning as these down here. I'll let you to think about that for the next 2 days of why would this atomic number be the same thing as this atomic number when we've got this variable and we've got this variable. We've got two variables named atomic number. How do we deal with this? All right? And we'll deal with it on Thursday.